Welcome to the electronics class for December the 16th. This will be our last class before the big winter break. After we come back from winter break, we will be taking the tests that I've been warning you about and the tests that I've been preparing you for. It's a test that I don't write, the state of Utah writes it, and they require that I have to give it to you. And I want you all to score really well on it. So that's why we've been spending so much time each day doing practice quizzes here. And we will again do the same thing today too. First, let's talk about last night's homework. So I'm looking at the scores right now, and I see that nobody got a perfect score, although some of you got close. And there is one problem on there that I think might possibly be the reason why some of you didn't get a perfect score. But 3 of you had not even tried it as of 10 minutes ago. 2 of you, looks like you're trying to do it right now. Those of you that haven't been doing the homework, guys, come on, you got to do the homework. That's the only way to learn this stuff is to sit down and do it. You can't just sit there and watch me do it and say, yeah, it makes sense. You have to do it yourself. Okay, so although some of you got pretty close to a perfect score, there are a fair number of you that did not really get close to a perfect score. So we have some work to do to prepare you guys for this big test in January. You know that sheet that I gave you that has all the schematic symbols on it? I would hope that you guys have printed that out. And every night before you go to bed, just set it by the side of your bed on your bed table there. And every night before you go to bed, just spend a few minutes scanning it. There really is a lot of brain research that shows that if you scan something, before you go to bed, right before you go to bed, just spend a few minutes looking it over, giving yourself a little kind of a quiz. And if you do it right before you go to bed, that really helps the brain to remember it. There's good scientific research to back that up. So that's what I'd like you guys to do. All right, let's do the homework first. Okay, so what you should be seeing right now on your screen is last night's homework. Okay, so let's do this kind of the same way that we've been doing it before. Question number 1, you've got 5 choices here. Can you please type in your answer into the chat box in a private message? I don't want everybody to see your answer. What kind of switch is that? You can see the 5 choices there. Everybody tell me what you got. Okay. All right, so I see most people are getting it right. In fact, the overwhelming majority of you are getting right, but there are a couple of you who are not. Okay, so let me ask. So Simon, you were the first one to respond with the correct answer. Can you tell us what is the answer and how did you know that it was the right answer?
So it's dp dt, and I know this because it's got 2 inputs and 2 outputs per input. Okay, so it's dipole dithread or something. Okay, dual pole dual thread.
Okay, throw is actually what it worked. Okay, so we got 2 inputs. So this tells you the number of poles. We got 2 inputs, so that means it's a double pole input. So then we know it's one of these 2, right? And so what Simon is telling me is that if you look at any one given input, you can see it has 2 possible outputs. So that means that it's a double throw. Okay, so that tells us that it is double pole, double throw. Right, and almost all of you got that right. A couple of you did not, but most of you did. Okay, next one. What kind of switch is this? Now, this time we don't see the schematic. The only thing that we know about this one is we know that there are 2 connections. So on the bottom there's 2 places where wires could be hooked up. That's all we know. Okay, I'm seeing some answers coming in. Okay, so those of you that are answering, you're getting it right. Ooh, up until the very last one there. Okay, Now the rest of them are right. But there's a couple of you who are not answering. If you don't know, just type IDK. Okay. All right. Okay, so we got responses now from pretty much everybody. All right, this time, let's see, who was the first person with the right answer? So it looks like Brian, you were the first person with the right answer. So tell us what the answer is and how did you know it was the right answer?
So I kind of knew it was like a right answer because like since there's two prongs sticking out, when you have a single pull, single throw type switch, there's only like one way for the electricity to go, and it's to flow in the circuit. Since this is a switch, it's meant to break or activate the circuit, and there's only one line to go through.
Okay, very good. Yeah, since there's only two places where you can connect wires, one of them has to be the input. The other one has to be the output. There's no other way that can be done. And so then we're going to have a switch in the middle there. Okay. So if you got one output, that means it's a single pole. And if you've only got one output, that means it's single pole, single throw. So yeah, that one, just thought about it for a sec, you can get it, and it looks like most of you did get it. Okay, how about this one? So you can see that it's a momentary switch. Now, I should have asked whether it's a normally on or normally off, but I didn't ask that. Single pole, double pole, single throw, double throw, what is it? So what do you got here? Type them into the chat box. Interesting. Okay. All right. In this case, most of you are getting it wrong. Okay. And so let's see how we know what it is. Okay. So each one of those dots there is a place where a wire is connected. And I don't remember if I explicitly said that last time. Maybe I didn't. So that means we got a wire coming in here, a wire coming in here, we got a wire going out there, and a wire going out there. Okay, so now that helps us know. So you can see we got two inputs. So there definitely it's a double pole. And you can see that each input only has one possible output. Okay, so that means it's a single throw. So the answer is double pole, single throw. Okay. All right. Okay, so I'm hoping that this review is helping you guys. There will be problems like this on the test, I guarantee it. Now, one thing that I didn't ask here, but let me ask it now. Is this a normally off or is it a normally on circuit? And by the way, this one actually is a trick question. Okay, in fact, let's just talk about it rather than taking the time. Do you see how this one is a trick question? If I were to ask whether it's normally off or normally on. So let's look at the two different paths that electricity could flow. So we got this pole right here and that throw out there. And we got this pole right here and that pole out there. So if I look only at the upper one, so if I just look at that one, you can see this is a normally on circuit, a normally on switch. So when my finger is not pushing the button, that upper one is normally on. But if you look at the lower one, you can see that when my finger is not pushing the button, that guy is not connected. So that one is a normally off switch. So if I were to ask you, what is this switch, a normally on or a normally off? The answer would be, well, they're both. I mean, one of the poles is normally on, but the other pole is normally off. So you can see why I didn't ask the question here, because it would have been a little bit tricky. Okay, question number 4. This is the one that I think got lots of you. I think those of you that didn't get a perfect score, this might be the reason why you didn't get a perfect score. This one is a little tricky. And in fact, you might even argue with my answer there. Okay, so I see some answers coming in, and some of the answers are exactly what I suspected might have been the part of confusion. Okay, all right, good. So let me pick on Jasper. Okay, Jasper, you said that the answer is that it's an XPYT switch. Now, I'm not confirming whether that's right or wrong. I can understand why you might answer that. But can you explain to everybody else, why did you think it's an XPYT switch?
Because if there's more than 2 inputs and outputs, it's an XPYT switch, I think.
Okay, I like your reasoning. So the problem, the thing that makes this question difficult to answer is all we know is that there's 6 pins. We don't know which ones are inputs and which ones are outputs. So let's see how this could be. I mean, it is possible that there's 1 input and 5 outputs. That's a possibility. It's also possible that there's 2 inputs and 4 outputs. Okay. It's also possible that there's 3 inputs and 3 outputs. All of those are possibilities. With the given information, we don't really have a way of knowing which one it is. So those of you that said, well, I think it's probably this one, therefore it's an XPYT, I can understand why you would say that. For those of you said, well, I think it's this one, therefore it's a DPDT switch, because there's 2 inputs, so that means it's DP, and each input has 2 possible outputs. So that's a DPDT. Okay. So this, in fact, is what it actually is. But I know that just because I bought the switch. The other possibility is that it could be this one. It could be a 3PST. So it's got 3 inputs, and each one of those inputs only has 1 possible output. So it could be a 3PST, it could be a DPDT, or it could be a 1P. Oh boy, my writing there is even worse than usual. In fact, my writing here is really bad too. Let's try these again. So it could be a DPDT switch. It could be a SP5T switch, or it could be a 3PST switch. Those are all answers that would all work based on the given information. So the correct answer, well, you could argue, I mean, is there really a correct answer? It could be either one of these. And now, in fact, it turns out it's a DPDT, but it could have been an XPYT. So if you got this answer wrong because you called it an XPYT, then send me an email and I'll go back and I'll give you the credit for it. But these guys, this is a very unusual switch. This is a fairly unusual switch. This is the more common switch, but it could have been any of those. And so this, I was thinking, is maybe the reason why some of you might not have got a perfect score, is because this was actually an ambiguous question. Next time around, I think I'll take this question out because it's ambiguous. All right, question number 5. So what kind of switch is this? Now, clearly it's a relay, but what kind of relay is it? Let me see what you guys put in here. Let me see your answers. Okay. All right, it looks like everybody's in agreement. It's an SPDT relay. Okay, very good. All right, excellent on that. Question number 6. We got 12 different pins on the bottom. Holy cow. There's all sorts of probabilities of what these could be. But there are definitely ones that it could not be. If you got 12 pins on the bottom, then we know there's no way it can be an SPST. Also, it couldn't be the SPDT, and in fact, it couldn't be any of the ones above. So there's only one possibility left over, is the YP or the XPYT, because there's no way that any of these others could have 12 pins. It just doesn't work out that way. Okay. And okay, so now this one, what is this one, guys? Okay. All right. Everybody's getting this one, right? Yeah, it's an SPST momentary. Now, is it normally off or normally on? Okay, everybody answer that one. Okay, so this one's a normally off. Okay, very good. All right, you guys are doing great, except a couple of you aren't answering. I'm noticing that there's several of you who are sitting back and not answering, so shame on you guys. Okay, how about this one? What kind of switch is this one? Now, in this case, the only thing we know about the switch is that there are 3 pins on the bottom. Okay. Now, almost everybody's getting this one right, but 1 or 2 of you are not. Okay. So if there are 3 pins on the bottom, then there aren't a whole lot of possibilities of what this could be. I mean, it could be 1 input and 2 outputs. And I don't know what else it could be. I mean, you might say, well, it could be 2 inputs and 1 output, but that doesn't make sense. That there's no switch that has 2 inputs and 1 output. That's not really a switch. So that one doesn't make sense. So I think our only possibility is this one. So that's going to be an SPDT switch. Okay. And now for the biggie here. This is one that I see some of you are still struggling with. I don't know. Should I take the time today to go over it? Because I think most of you are getting this. When I look at the specific answers, when I go into Canvas and I can see exactly which questions you got right and which questions you got wrong. And so, and if actually in this case you had to submit the file. So in this case, when I look at what you guys submitted, I see that most of you are getting it okay, but there's still a fair number of you who are not. So if you had trouble doing this one, and I mean, some of you didn't even submit a file at all. In fact, a fair number of you didn't submit a file at all. So this is something that I guarantee there will be a question like this on the test in January. You guys need to be good at this. So if you're still having trouble with these, let me suggest go back into Canvas and look at the recording. I'm not going to take the time to do it again today. I've done it before. I've done it multiple times, and it's all been recorded. So the recordings are posted on Canvas. If you go into Canvas and look at the previous recordings and watch how I did it, then you should be able to get it. And every single one of you, this is something I expect you all to be able to get. So please look at the recordings. Okay, well, that's it for last night's homework, but that's not it for the quizzes, for the quiz practice. I'm going to pick a couple of schematics right now, some schematic symbols, and I want you to be able to recognize just by looking at them what the schematic symbols are. Okay, so get ready to start typing into the chat box. Yeah, but again, make sure it's in a private message, not a public message. Okay, so this one right here. What is that the schematic for? Okay. All right, looks like everybody recognized. So everybody recognized, well, not everybody, almost everybody. Almost everybody recognized that this is a diode, but it's not just any kind of diode. It's a light emitting diode. Okay, so the arrows here are the thing that tells you that it's light emitting. So these things are intended to represent that light is being given off. Okay. Now, if the arrows was pointing the other way, if we had something that looked like this where the arrows are coming in, then that would be a light activated diode. Okay, but that's not what we got. What we got is this. So light is being given off. So this is a light emitting diode. If the arrows weren't there, then you would just say it's a diode. Okay, and most of you got it, but there are a fair number of you who didn't. So that has me a little concerned. You guys should know this by now. Okay, how about this one? What is this? Okay, the people who've answered have answered correctly, but some of you haven't answered yet. Okay, the people who are answering now are generally saying you don't know. Okay, all right. Okay, Lily, can you tell us what you think the answer was and tell us how you know that?
Um, a meter.
Very good. And how did you know?
I just remember when I was looking,
You just
studying
remembered
the thing.
That's an acceptable way. Yeah, you just remembered because we've seen these before. Okay, so any time that we're measuring something, if we have a circle with a letter in it, that tells us what we're measuring. So if we had a circle with a V in it, that would tell us that it's a voltmeter. If we have a circle with the ohm symbol in it, that would tell us that we're measuring resistance. And if we have a circle with a P in it, that would tell us that we're measuring power. You don't see those very often. They're kind of rare, but they do exist. Okay, so the A stands for amps. So Lily is correct in saying that this is an ammeter. Okay, now if you said amp meter with a P, then I wouldn't mark it wrong. But when they came up with the names, whoever came up with the names, they decided to leave out the P when they put on the meter. They just call it an ammeter. Okay. Okay. So Brian just put in an interesting comment. He said that the ones with asterisks are also voltmeters. Okay, I haven't seen that, but there's a lot of things I haven't seen. So I trust Brian. He's usually pretty good about when he says something, it's usually true. Okay, how about this one? What is this? Everybody type it into the chat box. Okay, I'm seeing some answers. And I'm seeing a few people admitting that you don't know. Okay. All right, this is one we talked about last week. Okay, so I am seeing a little bit of confusion, and it's exactly the kind of confusion that I anticipated. Okay. Most of you are claiming that this is a fuse, and you are right, it is a fuse. Some of you are saying that it's an AC power supply, and I can absolutely understand why you would say that, because the two are very similar. If I have a circle with this sinusoid symbol in it, okay, that is an AC power supply. Okay, that's something that produces voltage, and the type of voltage that it produces is alternating. Okay, so if you have the sinusoid squiggle inside of a circle, that is an AC power supply. If it is not inside a circle, then it is not an AC power supply. It's a fuse. And personally, I think that whoever came up with the symbols, I think this was a poor choice on their part, because it is so easy to get them confused. And I wish that they had come up with something that wasn't so confusing. But hey, they didn't ask me. This is the way they did it. And so you guys need to know. So if you see it like this, it's a fuse. If it's inside of a circle, then it's not a fuse, then it's an AC power supply. Okay, how about this one? What is this? Okay, I'm starting to see some answers. And some of the answers have question marks by them. And several of you are admitting that you don't know, and I appreciate your honesty there. A bowl with legs. Yeah. Okay, so those of you that did have an answer, you were mostly correct. This is a buzzer. Okay. Now, one of you said that it was a speaker, and I can see that it could be used either way. So if they were to ask you this on a multiple choice question in the test in January, if one of your choices is a buzzer and the other choice is also a speaker, then you're going to have a problem. But hopefully they won't do that to you. Hopefully one of your choices would be a buzzer and the other choices would all be something else, not a speaker. because this one could be either way, but normally buzzer is the one that it's used for, buzzer. Okay. Now, what's this one? Now, I'll tell you what, before everybody starts typing into the chat box, I'm trusting that you all recognize that it's some sort of a transistor. Okay, I would hope that everybody recognizes it's a transistor. So let me approach, hold on guys, don't put answers in yet. Let me approach this in steps. The first question I want to ask is, you know how there's two general families of transistors? If I take transistors as a whole, I split them into two different groups. One group is called a BJT, which stands for bipolar junction transistors. The other group is called a MOSFET, which stands for metal oxide semiconductor field effect transistor. So question number one, which of those two families does this guy belong? Is this a BJT or is this a MOSFET? Okay, I'm glad to see, ooh, rats. Oh, you were doing so well. Okay, almost everybody recognizes that this is a BJT. Okay, and the way that we know it's a BJT and not a MOSFET is because our input line is directly connected to this vertical line. And so that means if we send electricity in here, it has a path that it can follow to come out the other side. If this was a transistor that looked like this, okay, you see that there's a break. Okay, if I tried to connect up electricity to this and I want to send electricity into here, you'll see that there's a break here. The electricity here has no way of getting to the other side. Okay, so that's what makes a MOSFET, is that we apply a voltage over here, but the current cannot actually flow because there's a break. But in this case, the input gate there is connected, so current can flow. So this is definitely a BJT, whereas this one over here is a MOSFET. And almost all of you got that, and so good for you. Okay, so now we know it's a BJT. Next question, what type of BJT is it? And we got two choices, and I see that you guys are recognizing that, so good. Okay, all right, so you guys have recognized that it's either a PNP or an NPN. Most of you are saying that it's PNP, but a fair number of you are saying that it's an NPN. Let's see, who have I not picked on? Presley. You said that it was a PNP. Could you please unmute yourself and tell us, how did you know it was a PNP? What was your thought process?
I just remembered that if the arrow is on top and it's a BJT, then that makes it a PNP.
Okay, I cannot argue with that line of thinking. There's another way that I would prefer that you think about it as. How about Eric? You also said that it's a PNP. What was the thought process that you went through in recognizing that it's a PNP?
I just remember that when the arrow is going in from the top, that it has a P in it.
Okay, so basically the same as Presley.
Yeah.
All right, so let me tell you the thought process that I would prefer that you go through. I mean, what you guys did worked. So if that works for you, then hey, I can't complain. The thought process that I would prefer that you guys go through is whenever we're dealing with BJTs, remember that they are really just two back-to-back diodes. All right, so we've got a diode that looks like this. Okay, where the tails of the arrows are the same. And then the other possibility is that we got a diode that looks like this, or two diodes together that look like this, where the heads of the arrows are the same. Now, whenever you have a diode, okay, this side is the P side and this side is the N side. And the way that you know that is because electricity, at least the traditional current, if you consider current to be positive charges flowing through the wire, they always flow from the positive side to the negative side. And if the arrow is showing you the way that they flow, then that means they're flying from the positive side to the negative side. So this would be the negative side. The positive side is right here. The negative side is right there. In this case, this would be the positive side. This would be the negative side. This would be the positive side. So if you look at this arrow and think of it as being a diode, then this is the P side. That means this is the N side. Okay, and they're always back to back. Okay, so if we got a P up here, that means this guy is going to be a P2. So that means this is a PNP. That's the thought process that I would hope that you guys go through. Although those of you that got it right, hey, you know, whatever you did, it worked. But a fair number of you guys did not get it right. So, so think about that. Here's the sheet that we used last time. I don't think I need to say much more about it this time. I spent a lot of time talking about this before. Just on the right side, you see the BJT family, and on the left side, you see the MOSFET family. And okay, so hopefully you're good on that. Okay, now here I'm going to ask you a question where what I'm going to do is I'm going to say a word, and the word that I say is going to be the name of one of the connectors. Okay, so a transistor always has 3 wires going into it. Okay, so let's, and each of those wires has a name. All right, so let's suppose that I ask you which of those connectors is the emitter. Okay, so I want you to tell me, is that connection, is the emitter connection number 1, or is it connection number 2, or is it connection number 3? Or what I might do to you is I might give you a trick question where the emitter is actually not the correct name for any of them. And if that's the case, then I want you to respond by saying number 4 is that it's none of the above. All right, so let's start off with emitter. Okay, so if I were to ask you which of those terminals on the transistor is the emitter, then I want you to tell me, is it number 1? Is it number 2? Number 3? Or was this a trick question? Is it in fact none of them above? Okay, so I'm getting answers that are all over the board here. Okay, but I am seeing more 3s than anything else. Okay, and in fact, 3 is the correct answer. The emitter is in fact the lower one here. This, oops. This one is in fact the emitter. Okay. Now, what is this one up here called? Number 1. Can you guys type into the chat box, what is number 1 called? Okay, and then like, all right, so most of you are recognizing that it's the collector. Okay, good. So now how do we recognize that? How do we know the number, or what is the way that we can remember the number 3 is the emitter and number 2 or number 1 there is the collector? Okay, well, here's the way that we do it. Okay, this one up here is always the one that we connect to the positive voltage, and this one down here is always the one that we connect to the negative voltage. Now, if you think about current as being plus charges, then this is backwards, okay? Because emit means to give off, collect means to, you know, to gather up. So if this thing is called the emitter, what that means is that this guy is giving off stuff. And if this is the collector, that means that he's gathering stuff up, which is the exact opposite of the way that it works if you consider the plus charge as being the current. You know, in plus charges, they flow from here to there, which is backwards for the name here. Well, the reason it's backwards is because the people who named it this, they were not thinking about the traditional current. When they came around to naming this, they were looking at what direction do the electrons actually flow. Okay, so if the plus charges flow from the positive voltage to the negative voltage, if the plus charges flow this way, because that's the way that Benjamin Franklin he didn't even know that there was such a thing as an electron. So he just kind of guessed. Okay. And then later on, we found out that that's not actually what's happening. What's really happening is we have electrons, and electrons are flowing the other way. So the people that named the emitter and the collector, that's what they were thinking of. This terminal here is where the electrons are being emitted from. And this terminal up here is where the electrons are being they're all being collected together. Okay. So it does make sense that number 3 is the emitter and number 2 is the collector, if you think of it in terms of electron flow. Now, if it's not a BJT, if it's a MOSFET, kind of the same thing. So remember when I did this last time we met, I said that if it's a MOSFET, then these are the names we use. The control input is called the gate. The thing on the bottom there that's connected to the negative voltage, that's the source. Okay, in fact, tell you what, let me just go ahead and bring these guys up here like that. And remember, so if it's a BJT, we can put it on the left side or the right side. They're all, the name is always the same. Okay, so if it's a MOSFET, then this thing here that we would call the emitter if it was a BJT, well, hey, we call it the source. What does source mean? Well, source means the thing that gives off the electrons. And up here we call it the drain. What does drain mean? Well, it's the thing that collects the electrons. So you can see a drain is very much like a collector. A source is very much like an emitter. Okay, it's just that with MOSFETs, for whatever reason, they decided that they would call it a source instead of an emitter. Okay, and then the terminal that controls the transistor, the terminal that determines whether the transistor gets turned on or not. Okay, well, if it's a BJT, then we call it a base. If it's a MOSFET, then we call it a gate. Okay, so let's suppose that you're taking the test next January, and they give you a question like this, and they ask you to say which of these terminals is the source. Okay, is the source number 1? Is it number 2? Or is it number 3? Hopefully you would recognize that we got a problem here, because this picture here is a picture of a BJT, and source is the wrong word to use if it's a BJT. Source is what we would use if it was a MOSFET. So the correct answer, if they were to ask you this question on the test in January, the correct answer would be none of the above. Okay, so the source would be this terminal right here if it was a MOSFET, but because it's not a MOSFET, we don't call it a source. Okay, we call it an emitter. Okay, all right, so hopefully you guys are good with that. All right, I'm thinking that's probably enough on the quizzes. So I don't want to quiz you guys so much that you get sick and tired of it. So let me stop there. We are going to do this again when we meet after the winter break. I'm going to spend maybe 1 or 2 more days just giving you practice here with these quizzes, because I want you guys to score really well on the test. Now, the way to score well on the test. So let me go into here. So you should be seeing my Canvas page right now. So let's click on electronics and go into the modules. And then let's scroll down. Okay, here we are. Okay, so this item that you see right here in module 5, the very first thing in module 5, list of electronic components you need to know and their schematic symbols. Okay, please, everybody, click on there, go into here, click on the words here. When you click on that, what you will see is it will download a file. So if you're using a Chrome browser, then down here in the lower left, you'll see it's going to download the file. And so now you can print the file out. Now, if you don't actually want to download it, you can click on here and it'll show you here. But I would prefer that you download it and print it out on a piece of paper. And this is what you'll see. All of the different schematic symbols that might be on the test in January, 3 pages of them. So please, everybody, I want you to print this out and put it by your bedstand. And every night before you go to sleep, just spend 5 minutes, just kind of cover them up. So take one hand and cover up the things on the left side. And so you just look at the thing on the right side and say, okay, what is the symbol for a polarized capacitor? And then uncover it and see, did you get it right? Or do it the other way around. You know, cover up the things on the right and then just look on the one on the left and say, okay, so if I look at that, what is that? Okay, so spend 5 minutes before you go to bed every night, and then you'll get a really good score on this test in January. Okay, so somebody just asked me, when exactly is the test? Well, the date for the test hasn't been set yet, but it'll probably be the second week in January, which, by the way, will be the last week of this class. So this, as you know, this is not a year-long class. This is only a half-year class. So I think January 13th is the date that sticks in my mind. I think that's the end of the term, is January 13th. So probably we will take this test on the last day of the class, although we might do it on the day before the last. We'll see. It hasn't been scheduled yet. So everybody, please do that. And spend time just reviewing those before you take the test. Let's see, one thing that probably would be good to do. Let me show you a couple things here. Let me stop that share and start a new share. One thing that they might do to you in January is they might show you some pictures. And so what you're seeing on the screen right now, okay, these obviously are pictures of switches. So these are slide switches. One of the switches here has something written on it. You see the switch on the right there? It may be hard to see, but I think you should be able to see it. So if you look at the letters and numbers that are written right there, you can see it says 3A 250V. What that means is, if you were to connect up some wires that had 250 volts on them, then 3 amps would be the maximum that this switch could handle. If you try to put more power through this switch than that, then the switch will get hot and it'll blow. But maybe you're not using 250 volts. Maybe you're only using 125 volts. If you use 125 volts, then instead of 3 amps, then you could get 6 amps through there. So why is it 3 amps sometimes and 6 amps other times? Well, because the designers of the circuit here, they're worried about how much the switch is going to heat up. And the thing that causes a switch to heat up is power. Power equals heat. Okay, so you can see I've asked the question here, well, how much power can this switch carry? So what I'd like you guys to do is I'd like you to do a little calculation here. And let's do it assuming that we put 250 volts and we have 3 amps of current. Can you guys just type into the chat box, how much power does that correspond to? And hopefully you remember. Okay, looks like you guys do remember. Okay, very good. All right, it looks like pretty much everybody is agreeing that it's 750 watts. Okay, so it sounds like you guys recognize that power is defined as the amount of current times the voltage. So if I have 3 amps times 250 volts, that works out to be 750, whatever units it is we use to measure power in, which is watts. Okay, Now, I'd like you to redo the calculation using these other numbers, okay? So instead of 3 amps and 250 volts, let's use the other one. So it's 6 amps and it's 125 volts. Do the math and what do you get? Hey, you're getting the same answer. Oh, isn't that funny? Isn't that an interesting coincidence? It's not a coincidence, okay? 6 times 120 works out to be the same thing as 3 times 250. So basically what it means is when we're trying to figure out how much heating this switch can tolerate, it's the voltage is only part of the picture and the current is only part of the picture. The complete picture is the two of them together. The complete picture is the power. That's what determines how hot this switch is going to get. So this switch can handle 250 watts of power, and there's a lot of different ways you could reach that. So here is what they might ask you in the on the test in January. What if we were to put a 12-volt battery up here? Then how much current could this switch handle? Okay, so we've just decided that this switch can handle 750 watts of power. As long as the total power is less than 750 watts, we'll be fine. So if we were to connect a 12-volt battery, then what is the maximum current that this switch could carry? Okay, I see that one of you has answered. Let's get the rest of you in here. What is the maximum current that we could handle if the maximum allowed power is 750 and the voltage is 12? Okay, I'm seeing a few of you are typing in answers. And so far, all of the answers that have been typed in are the same answer. So that's, oh, rats. Up until the last one, they were the same. That last one was not the same. Okay. All right, let's see. Caden, you were the first one to give me an answer. Can you unmute yourself and tell us, how did you calculate this?
I divided the maximum power by the voltage to get
Okay.
the
Okay, all right, good. Now, the way I would recommend that you guys approach this is I would recommend that you start by writing the equation that relates everything. Okay, so we know the power equals current times voltage. So what is it we're looking for? We're looking for current. All right, so what we're going to do is we're going to take this equation and we're going to algebraically solve it for current. All right, so the way we're going to do that is let's divide both sides by V. So that goes away. So that tells us that I is equal to P divided by V. So if P is 750 and V is 12, so then whatever 750 divided by 12 is, which the majority of you guys are saying that it's 62.5. And so I'm going to go ahead and trust you. So the answer there is 62.5. So that means if we're only using a 12-volt battery, we could put 62 amps through this switch and it won't overheat. But if we're using a 250-volt battery, then we'd better not put more than 6 volts or 6 amps through it, because if we put more than 6 amps through it at that higher voltage, then it'll overheat. So you can see why power is very important. Okay, and one other thing I just want to warn you about, so this is not really quiz here, this is just warning. A lot of times people look at a switch and they think that it's a momentary switch because it looks like a momentary switch, right? I mean, the switch in the upper left here, this is the switch that we've been using on Tinkercad for a while. Okay, that was a momentary switch. You push it and it comes on, you take your finger off, it goes off. So all of these switches that you see down here, they look the same. You know, they're push button switches. And so you say, well, they look like they're momentary switches. Maybe they are, but maybe they're not. A lot of times you'll see switches like this that they're actually latching switches. And the way that they work is very much like on your pen. Any of you guys have a ballpoint pen? Oh, I thought I had one. Oh, here, yeah, okay, yeah, I did, okay. So, okay, here's a ballpoint pen. Here's a push button, okay? When I push it the first time, it stays down. Even though I take my finger off it, it stays down. It's only when I push it the second time that it comes back up. So these switches that I just showed you, they look like they're momentary switches. They look like if I push it once, it goes on, and if I take my finger off, then it'll go off. But depending on how the switch is designed, it might in fact be like your ballpoint pen here. It might actually be a latching type pen. So be careful. Just because it looks like a momentary switch, that doesn't mean that it actually is a momentary switch. Okay. So new stuff. All right. So when you guys go onto Canvas and you go into the modules, you're going to see that I have put a new module on there that wasn't there before. And this is a module about how to solder. So what I want you to do is I want you to click on this module. Let me hit preview here so that it looks like what you will actually see. Okay. And you'll see that I've got a video that talks about how to solder. And I've also got a link to a website that talks about how to solder. And then down on the bottom, I have a whole bunch of questions about soldering. That's your homework, is to answer those questions. But first off, let me just throw out the question. What is soldering? I'm sure that many of you know, but I'm also equally sure that a lot of you probably have no idea what soldering is. So if you are one of the people that thinks you know what soldering is, would you please unmute yourself and tell the rest of us, what is soldering?
It's like you have a really hot like little metal rod and you sort of put it up to like, it's a wire that has like something inside of it and you push them together and it just sort of melts and you can stick things together like that. Okay,
very good. Everything you said is true. Anybody want to add to that? Somebody else. Tell us what is soldering. Not that Henry didn't do a good job, but you know, there's a lot of ways you could describe it. What's another way that you could describe it? And Brian, I see that you typed something in the chat box that looks very informative. Can you maybe unmute? Okay, looks like Luke beat you to it. Go ahead, Luke. What is soldering?
Isn't soldering like conjoining two electrical components? You can conjoin two electrical components by melting some sort of substance that is conductive and therefore conjoining the two electrical components together.
Excellent. Okay, very good. And that's pretty much what Brian said in his chat message. Yeah. Okay, so let's suppose that I've got two electrical components. Let's say I've got a photoresistor here and I've got an LED. Okay, now I could use a breadboard to connect these guys up. And in fact, when I'm just doing prototype testing, that is what I'm going to do. I would use a breadboard and I would plug these guys in the breadboard and I would check my circuit and I would make sure that my circuit is working and make sure that the LED lights up when I want it to light up. Okay. But then once, if this is a project that I want to keep forever, then I don't want to keep it in a breadboard. A breadboard is only for prototyping things, for temporary stuff. If I want to keep it forever, what I'm going to want is I'm going to want to connect these wires permanently. And so what I can do then is I can take the wire from my photoresistor, the wire from my LED, and put them together. And I want to connect them together permanently. So solder, you could think of it as if it's hot glue, but it's a very special kind of hot glue. It's a conductive hot glue. So imagine you take a hot glue gun and you put a special kind of a stick in there that's not the normal hot glue. It's a metal stick that has a very low melting point. So then you melt the metal and then you use that metal to hot glue these two guys together. And then when the metal cools down, then these two guys are connected together by a conductive hot glue. And so electricity can flow through it, and so it's really good. So that's the way that I like to think of it, okay? Now, obviously, we don't want to use a hot glue gun for it. If we got melted metal inside the hot glue gun, that's going to cause a big mess. So what we do instead is we take a special long rod, and I don't have one with me here at home. I left it at school. So imagine that this pen is a heated iron. So it's an electric iron, you know. So I plug it in the wall, and the metal gets hot, okay. And then what I do is I take a piece of solder. You know, in this case, it's just a straw, but pretend that this is a piece of that special conductive hot glue, which is called solder. And when I touch them together, then this is going to melt. And so if I take my LED and my photoresistor, if I put them together like that, and then I use the hot iron to heat them up, and then once they get hot, then I bring in the solder and I touch the solder to the hot connection, then the solder will melt into the connection, and then when I take it away and let it cool, then they have been soldered together. Okay, now, it sounds simple in theory, and in reality, it's not really that complicated, but there are a lot of things that can go wrong. If you don't solder properly, you will not get good connections. Yes, cold solder joints. Very good, Brian. Yes. And there's a whole lot of things that can go wrong. Now, I don't want to spend today talking about soldering because I think that this video that I've shown here, I think this video does a better job than I personally can do. So rather than me tell you anything more, here's what I want you guys to do. With the remaining time we have in the class, by the way, we've got 40 minutes left before the bell rings. What I want each one of you guys to do is to go on to Canvas. I want you to click on this video. I want you to watch the video, pay close attention to the things that they say. And then, even though you've watched the video, I still want you to go and I want you to click on this link here, because when you click on this link, you see how to solder a beginner's guide. They say a few things in this web page that the video doesn't talk about, and things that I think are important that you should know. So this is very important, guys. Don't just watch the video alone. But then by the same token, don't just read the website alone either. I want you to do both the website and the video. And then after you've done that, then I want you to come in and answer all these questions. Okay. Now, some of you might know that in a case like this, is it better to watch the video first and then look at the questions? Or is it maybe better to look at the questions first and then watch the video? What do you guys think about that? I'm sure your other teachers have talked to you about study skills. Okay, this is a good generic study skill. Okay, so Presley, I see you just typed an answer in the question into the chat box here. Can you unmute yourself and tell the rest of the class why did you say what you just said in the chat box?
I usually like to have a general understanding of what I should know. Like, I study more than just the questions, but I like to have an idea of what is specifically required for this specific task.
Yeah, because if you know ahead of time what the questions are going to be, then you know what to listen for. So while you're watching the video, I hope you're taking notes. And while you're reading the website, I hope you're taking notes. So if you know ahead of time what the questions are, then you know what to pay attention to while you're watching the video or reading the website. So this is true for all classes, not just this one. It's always a good idea to know what the questions are before you watch the video. But sometimes, you know, it's not possible. Sometimes the teacher doesn't tell you questions ahead of time. All right, so we still have 15 minutes remaining in class. You guys know what to do during that time, right? Any questions? All right, well, I will not see you guys again until next year. So let me wish you happy holidays, happy new year, and I will see you in January. So you can go ahead and type "bye" into the chat box, or if you want to say happy holidays in the chat box, that'd be even better. And then you can go ahead and log off. And I will go ahead and end the recording just in case you had a question you wanted to ask that you didn't want to get recorded.